Hi everyone. So the first time I did this, I had difficulties. So hopefully this second time around, things go a little bit better for me. So your next unit, your next really big topic is going to be called exponential functions. And so before we start that next week, I want to take some time to review exponent laws with you. This is one topic that you should have covered briefly in 8th grade. So I need you to kind of go to that filing cabinet that is your brain and open any files that you have regarding exponents and exponent laws. So hopefully by the end of this review, you could at least name one of the exponent laws and give examples. All right, so let's get started. We'll start with the very basics. So what is a base? What is an exponent? Okay, here's an example. The base is the term that's being multiplied, and the exponent is the number of times the base is multiplied by itself. It's how many factors of the base that you're going to have. So I would have 5 factors of b in this example. Okay, so if you take a look at these two expressions, is there a connection between them? Okay, so if we take a look at 2 cubed times 2 cubed, if my base is 2 and my exponent is 3, that means I have 3 factors of 2 being multiplied by 3 factors of 2. So do you see now where the connection between this expression and this expression comes from? 2 to the 6th would be 6 2's being multiplied together. And so you see that the two expressions are equivalent. So in other words, 2 to the 6th power is 2 cubed times 2 cubed simplified. There are 6 2's total. And that leads you to your first exponent law, which is product of powers. So when two powers that have the same base are being multiplied, you add the exponents together. So 3 and 3 are the same base. So I can add the exponents 3 and 2 to get 5. If you didn't do that, what you would be left doing is multiplying out 3 3's and 2 3's. So the 5 here is coming from how many factors of 3 are being multiplied in total. Adding these exponents is a lot faster, more efficient than actually writing it out every time. For example, if I have 4 to the 5th power times 4 to the 6th power, I don't want to have to write out 5 4's and then 6 4's because that's going to take a lot of time. It's much faster to just say 5 plus 6 is 11, right? Because 11 4's, that takes a while. Okay? So same bases being multiplied, add the exponents. All right, take a look at these two expressions, 3 to the 4th over 3 cubed and 3 to the 1st power. Is there a connection between them? So what we're going to do is expand the first expression out. We've got 4 3's in the numerator, 3 3's in the denominator. How does that become 3 over 1? Well, 3 over 3 equals 1. And 1 times a number is that number. So they just kind of cancel out is what most of you say, that it just equals 1. Okay, so how does that relate to 3 to the 1st power? Well, 3 to the 1st power is 1 3. So the two expressions are equivalent. In other words, 3 to the 4th over 3 cubed, or divided by 3 cubed, is 3 to the 1st when simplified. So when you're dividing two powers that have the same base, you're going to subtract the exponents. So when same bases are multiplied, exponents are added. When you're doing the inverse operation and dividing bases that are the same, you're doing the inverse of adding, subtracting the exponents. Okay, and here's your previous example, and it's just much faster to do this than expanding it out. So again, if I have something like 4 to the 12th power, who wants to write 12 fours over 4 to the 6th power, I would subtract my exponents, 12 and 6, so I have 4 to the 6th power. Just as another example for you. All right, moving right along. Power of a power is your next exponent law, and that is to find the power of a power, you're going to multiply the exponent. So it's almost like you're distributing that exponent outside to the exponent inside in a way. Or you can think of it like this. You have an exponent of 2 outside here. So that means I have 2 groups of 3 2s. For a total of 6 2s. But it's cumbersome to have to expand that out, especially if you have very large exponents. So it's faster for you just to multiply them. So for example, if I had 4 to the 4th quantity to the 3rd power, or cubed, I don't want to have to write out 3 groups of 4 4s. It's much faster for me to multiply those 2 numbers together so that I have 4 to the 12th power. Again, you could write it out 3 groups of 4 4s, but these exponent laws are basically just shortcuts to getting the answer, so you're not having to sit there and expand it out every single time. So the next exponent law I want us to take a look at will require you to kind of look at a pattern. So I have 2 to the power of 6 on down. So what you should notice, hopefully on the left-hand side, is my exponents are decreasing by 1 every single time. So I'm just counting backwards by 1. Okay. What might be a little bit more challenging to notice or understand, figure out, is the pattern on the right-hand side. What is happening going down? I'm not looking from bottom to top. I'm looking from top to bottom. What is the pattern? Okay, so it's dividing by 2 every time. So 64 divided by 2 is 32. 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. And 4 divided by 2 is 2. So 2 to the 0 power has to follow that same pattern on the right-hand side. You're not all of a sudden just going to randomly put 0 here, because 2 divided by 2 is not 0. 2 divided by 2 is 1. So 2 to the 0 power is 1, which leads us to our next exponent law. Any non-zero number to the 0 power is 1. Any number raised to the power of 0 is 1. So it's one of your easiest exponent laws to remember, but it's one of your most important. You could have a Google raised to the power of 0, and it would still be 1 as your answer. Okay, let's take a look at that same pattern and continue it one step further. So again, we were dividing by 2 every time, right? And we're still looking from top to bottom. What's our pattern? We're dividing by 2 every single time. Every time your exponent goes down by 1, you are dividing by 2. So if that's the case, again, you're going to still continue this pattern of dividing by 2. You're not all of a sudden going to break pattern just because you feel like it. Okay, so 2 to the negative 1, a lot of people would automatically say a negative number. But that is incorrect because if we follow our pattern, 1 divided by 2 is a half, or 0.5. Okay, so that leads us to your next exponent law, which is just negative exponents. Okay, any number raised to a negative power is 1 divided by the number to that power. So basically the term. Okay, so one thing I want you to remember is whole numbers technically can be made a fraction with a denominator of 1. So if I have a negative exponent, I'm going to move the location of that term to either the denominator or numerator, depending on where it starts. So this term is starting in the numerator. To make the exponent positive, I'm going to put it in the denominator. This is not why it works. This is not an explanation as to why the negative exponent goes away, but it's just a shortcut to remembering what to do. So if you have 3 to the negative 5, okay, and I want to simplify that term, technically it's 3 to the negative 5 over 1. I'm going to take these two. I'm going to take 3 to the negative 5, and I'm going to move it to the denominator. And it's positive now. Okay, and if your question says to solve, then you would have to determine what 3 to the 5th power is. Now, what if you have a term in the denominator with a negative exponent? Let's say it's 5 to the negative 2. Okay, what you're going to do is you're going to take the term and move it to the numerator. Okay, so you have 5 squared now over 1. So it's just 5 squared. So that negative exponent, you cannot have a negative exponent in a simplified term. Otherwise, the term's not simplified as far as it can go. So to make your negative exponent positive, in summary, a quick shortcut to remember, change its location in the fraction. Okay? So these are not all of your exponent laws technically, but those are the most pertinent to our next unit on exponential functions. Hopefully that, combined with your prior knowledge from 8th grade, is a good review for you. And then I have the quizzes for you to complete as well. If you have any questions, let me know, and we will figure out a way to communicate to help you better understand. Thanks.